Hello, everyone, and welcome to today's webinar. So, I hope all of you would have had a great Diwali. So, happy Diwali from Team Spaceonova too. So, today we will be discussing about a citizen science project that is RAD at Home, and a little bit more about that. So, RAD at Home is India's first citizen science research project in astronomy, and it was started in 15 April 2013, and till now it has trained more than 150 trained citizen scientists and e-astronomers. And any students can join this project if they are undergraduate or if they are graduate. And it was started by Dr. Ananda Hota with the motive of gathering unlimited potential of network of STEM undergraduates and graduates of India, then forming a research group. So that's like the students can directly participate in research and they can get exposure of the research as well. That will help in catering the rising big data problem in astronomy with mega telescope projects like GMRT, SKA, TNT. Now, this project, the RAD at Home, has also been identified and recognized by Nature Index, SKA, which is one of the biggest radio telescope under construction, and the IAU, the International Astronomical Union. Apart than that, a bit more about our guest teacher, which is Dr. Ananda Hota. So he is the principal investigator (PI) of RAD at Home Astronomy Collaboratory India. He is a UGC faculty. UMDAE Center of Excellence in Basic Sciences, India, and he is also a member of the consultative group under the PSA of to the government of India. So that was about Dr. Ananda Hota, and today he will be discussing about the Citizen Science Project RAD at Home, and we will be doing a case study of that. So welcome, sir. Good evening.
Thank you very much for inviting me. And it's always a pleasure to
Yes,
get connected to the public, especially because I'm
yes,
doing
sir.
citizen science research, part of my mission. Welcome,
Yes, sir.
everybody. Um, I'm kind of a bit informal person, but I'm always ready to answer whatever astronomical questions you have, whatever citizen science related research questions you have. This is a public speaking, so we will not go that much informal. But in my Facebook group, where there are nearly 5,000 people, whenever you come, we are ready to discuss anything. Um, Now, coming to the topic that the organizer has arranged with me, uh, it is a citizen science research. The moment we listen citizen, it sounds like something politics, something activist, something humanity topic. But why do people call citizen science, and more precisely citizen science research, is very interesting, and anybody can participate there. You may have wondered that why this new word is coming. People used to have the amateur astronomy. Why there is
Mhm.
new word like citizen science research, citizen scientist. So we'll talk exactly this fine differences. Why a new word had to be coined, or new trend rather picked up recently. And we will not focus on other topics, but briefly discuss what is citizen science research. We'll focus on astronomy, okay, and we'll focus on Indian astronomy citizen science research, so that I will try to present a complete picture of what is happening in Indian citizen science research, why this is so low or why this is so high, why this is good, why this is important. Many aspects we'll talk. So, to properly start my talk, I will share my screen and mm, wait for a half a minute. I will start from there. Okay, I am sharing my screen.
Yes, sure, sure. And it's like any student who has never heard about citizen science before, or if they're interested in astronomy and they want to do something like that, they just want to get started. So we hope that this webinar with sir will be very helpful for you guys. So just a
So,
second, yes.
huh,
Your screen is visible. Yes, sir.
yes. So, citizen science research in astronomy in India. I am leading RADatHome Citizen Science in Astronomy. So I will present more specific to RADatHome, But the first half of the talk, or one fourth of the talk, will be in general. What is citizen science research in astronomy in India? So this was your poster that I was displaying. What is my talk? And this is what is the poster for RADatHome. Many of you may be recognizing, of course, apart from a map of India, the GMRT radio telescope, giant meteorwave radio telescope. 45-meter diameter, 30 of them spread over 25 kilometers near Pune. This is world's largest kind of dish radio telescope. So what is this RADatHome logos all over India? These are the 150 trained citizen scientists of RADatHome who have been trained for 1 week in different research institutes. Different research institutes like Institute of Physics, Center for Excellence in Basic Sciences, in ICTS TIFR, in Nehru Planetarium and Vigyan Prasar Combined Approach, in Harishwar Research Institute. There are different institutes who had supported this for 1 week long free training. And there are many more organizations, logos that they had put. They have helped in one-day programs. One-day programs, what we call ODRAW, one-day RADatHome astronomy workshop. And the previous one-week program is RADatHome Discovery Camp. One-day programs are hosted by many institutions. IIT, ISER, Stephens College, this is NICER, and many other institutions. More than 2 dozen institutes are supporting this. In that one-day mode, we have trained actually more than 1,000 people. In basic first step, when this GMRT radio telescope looks at a galaxy's image, looks at the star's sky image, what does it see? Can I make an image of multi-wavelength galaxy images and try to understand what is the radio telescope showing? Because the radio telescope does not see those stars that you see. It sees something else. It sees entirely something else different. Hardly any star. The brightest stars is not visible to GMRT. The constellation that you see, the most important thing, constellations that you see in the night sky with the naked eye, those constellations are not visible to GMRT, although it is the largest radio telescope. So in those kind of one-day programs, people understand what GMRT sees. How do you compare the radio image of a galaxy and optical image of a galaxy? How do you compare the ultraviolet, optical, infrared, X-ray, radio images of galaxies? Primarily, actually, you see the plasma that comes out of the centers of galaxies, relativistic plasma, magnetized plasma that comes out of centers of the galaxies because of matter falling into the supermassive black holes. We'll talk about that soon. So, this is basically is the bottom line. And as far as Racing has already introduced my identity, my affiliation, I'm a UGC faculty at University of Mumbai, Department of Atomic Energy, Center for Excellence in Basic Sciences, member of International Astronomical Union, Square Kilometer Array, the biggest radio telescope that is being formed, and Principal Scientific Reviewers Consultative Group's member, Astronomical Society of India. You automatically have many affiliations, automatically you go. I get salary from UGC, I work precisely in CBS. So, if you think of the science, what kind of science being a member of participating with RADatHome 1 will do? It's basically driven by what kind of science I can do or I can lead. Because I started this group and the students. So this is the discovery of the exotic galaxy Speca in 2011. A radio galaxy, red is the GMRT image, blue is the American VLA telescope image, and this one is the optical picture. Second one, the cosmic leaf blower galaxy, NASA, JPL, Caltech press release, and this the green will be the radio and the galaxy. The black hole picture, I am not part of this, but this is what has become the icon for black hole observation. So Basically, with the GMRT, we will be focusing on how galaxy and black holes evolve by looking at UV, optical, IR, radio data, sitting at home anywhere in India, free of cost. That is the bottom line. Being part of this citizen science program, we will be working on this aspect of science. Multi-wavelength observational study of black hole galaxy co-evolution, primarily using GMRT data, our own pride of the nation, because that is the largest in the world, such radio telescope that we have built. And citizen science research is the approach that we'll be taking. Let's move. So, what roughly the outline of my talk will be this, that I will look at NASA IDS, Astrophysics Data System, Wikipedia, and Google's view of what is there in the internet talking about citizen science research in astronomy in India. Because it is impossible to find out the complete information about anything. We will talk to people, we will talk to different people, go to different organizations, read literature, and search in the internet and find out. Citizen science research in India, what is specifically happening, in which kind of topic, which kind of group, I will try to describe that. Why do citizen science with RADatHome and GMRT? I will explain the very strong logic behind that. Why should students and even citizens who are science educated should participate in it? There are personal reason why I want. There should be personal reason why it should be helping your personal career growth or academic hunger satisfaction, and why a country like India also needs it. Okay. How citizens should participate in RADatHome? I will describe the basic process. How simple it is, just by using Facebook almost, the interacting platform. There's some success stories I will describe to you, that how participating in citizen science research, one is actually going to help career and help the society in multiple ways. So what is citizen science? Okay. Citizen science is basically community science, crowd science, civic science, volunteer monitoring, online citizen science. Various name has been given. What is that basically? That public who are not scientists by profession I mean by trained to do research as well as paid for doing research, those they are not part of this research as the main component. They are the leader, they will be guiding, they will be teaching, they will be driving, but involving the non-scientist to define whether anybody can participate because they are citizen. You do not require a citizenship certificate here. But still, what we call in RADatHome is any BSc B can do research. Various citizen science program can have a very simple, very low level education level. If I say that anybody can do research, that doesn't mean that who is not illiterate can also do research. Anyway, so citizen science is participation at an amateur level, non-professional scientists for a well-organized, guided, and well-driven towards research outputs. It is not an education platform. Education is part of it, but it is not the education platform. Okay, research has to be there. That is why people get confused. That's why I need to focus on the research part. Citizen science is not education. Not everything is available publicly. Whatever you do is for public, by the public, fine. But there is a proper way that science research is taken. That proper way, follow a particular standard, follow a particular discipline, follow a particular hierarchy, follow a particular publication method. It has to be peer reviewed. It has to be passing through a certain level. Only then the publisher should publish your research paper. It is not a blog posting, right? That whatever comes to my mind, I have access to internet, I can post it. It's not Facebook post. The most famous astronomy platform in citizen science is nothing but Juniverse or Galaxy Zoo project. This has nearly 2 million people joined in this web platform. The astronomer Chris Lintott, he and some of his students, colleagues, etc., they started this. So the point to come here is, how do you create your online platform for the public in large number to participate and still contribute to a organized research output? Citizen science platform is not anybody can come and do anything and that anything comes out of it. It has to be a well channelized way of producing some scientific research result. Though large number of people participate, there has to be, that's why proper software channel, proper software platform, proper way of making your contribution pass through the scrutiny and then get published. You do get recognized as a co-authorship in certain good contribution cases, or simply you will be acknowledged that you have contributed to certain amount of research. So NASA has a astrophysics data system. This is called NASA ADS, NASA's astrophysics data system, where if you search citizen science and astronomy, all the paper published their abstracts. The best paper that comes out automatically with highest citation is nothing but Ideas of Citizen Science in Astronomy, a review paper, annual review of astronomy astrophysics. In that review paper, most reputed review publication system, RADatHome is the only citizen science research mentioned in this paper. Ideas of Citizen Science Research, a huge review paper published in 2015. 2013 we had already launched RADatHome, so they recognized that part. So Chris Linton, I said Juniverse, one leading astronomer for Juniverse, and other people from Cavalli Institute, Oxford University, they have participated in writing this review. So after 2015, some people may have started citizen science in astronomy from India. So I will go by some newspaper clippings also. So list of citizen science projects given in Wikipedia. In Wikipedia, if you look at, then you can see, as much as possible, the public has contributed to it. It is not the published paper by a research scientist. It is the public who is contributing to this list. And in this list, I search for the keyword India, wherever India description is there. Of course, RADatHome is there. Then the bio riddle, bird count, city nature challenge, biology, frog watch, India biodiversity portal, season watch. So unfortunately or fortunately, whatever you call it, there is nobody doing physics related thing. There is nobody doing chemistry related thing. There is nobody doing astronomy related thing except RADatHome. Everything is kind of tracking the nature from large 3,000 kilometer Indian landscape. People are tracking tree, frog, fish, climate, nature, birds, everything. But why then the physics chemistry research is not happening? Is it that the universe also doesn't have physics chemistry except astronomy? No, they do have. It is somehow the data creation for a citizen science research in India is not happening in other branches in that large quantity. Or citizen science research, which started in Oxford and Johns Hopkins University 2007, Universe project basically, still has not started in India properly. That the major research institutes are taking over as a huge amount of contribution from the fund, government fund. It has not happened yet. Whatever I am saying that 24 institutions are helping RADatHome, that is very minor level, hosting programs. It is not yet a major project in any research institute yet. Okay, coming to Google, after Wikipedia, NASA IDS, Google I searched Citizen Science Astronomy India. Top all you can see RADatHome, about us RADatHome, meet the citizen science whose chase stars, Times of India report that I will be showing you. Citizen science public websites. This is Star Telescope's website. Everything is there. There may be reports coming after there with certain amount, but you can see the prevalence or dominance, whatever you call it, the amount of research in astronomy that RADatHome is doing in the field of astronomy is very popular, at least. Okay, not to talk about hyping our own case too much. How citizen scientists are shaping the future of Indian research. This is a very recent article. Vantika Bhuya, maybe a couple of weeks back, this news was published. And there is from astronomy and the RADatHome is the only platform in an organized way that is doing. Another one, they study stars, they help predict landslide, they meet India's citizen scientists. This is one of the RADatHome member, Pradipta Mohanty. It lists all astrospace related. It's only one. Meet the citizen astronomers who chase stars. Times of India article. Of course, it has our leading member there in this news also, but it also lists IACS, International Asteroid Discovery, International Astronomical Search Collaboration or something like this. Basically focuses on asteroid search, international platform. It's supported by NASA. And the Akash Ganga Center for Astronomy, another, they also do very good asteroid, meteoroid research actually. So very few people are actually, it of course has named IIT, some Pune University person, etc. They are trying to do, but a small group trying to do it locally with the data from some website. This is not citizen science. Any citizen doing some science is not citizen science. Like you go for a star watch, sorry, uh, night star party, going to watch night sky, you are a citizen, you are doing astronomy, you are doing science, learning science, and watching stars is not citizen science research. It's amateur astronomy, absolutely fine. You are learning the tricks, absolutely fine. Whatever you observe, couple of observation with your telescope or your photometer or CCD, whatever, you contribute to a website who is compiling all the data set. And then they publish the paper. That does not mean that you are doing citizen science. You are contributing to a citizen science being done by somebody else. That way, a lot of people say that we are doing citizen science, we discover asteroids. But who is discovering? You are only contributing it. Who has supplied the data? Who has done the research work? Who has led the project? Who has published the paper? Where is Indian Institute there? Where is Indianness there? So something at least you should be producing the data from Indian telescope. You should be producing the paper with Indian leadership. That aspect is yet to come in Indian astronomy research in citizen science, except RADatHome. So this is a square kilometer array website, which will be, you can say, 10 times bigger than the GMRT. And so many different countries are participating in this. Canada, China, India, a lot more, Australia, South Africa, many countries are participating because it is not possible to make such kind of telescope anymore for a single country. So that's why everybody, for science, everybody unites. For example, you may or may not be knowing that the GMRT time is free for everybody to use. All scientists from all over the world. So this website informs the public that what kind of citizen science projects goes all around the world in radio astronomy, because the radio telescope, SCA, square kilometer array. They list many other things. Out of this thing, RADatHome is one of them. Universe is, of course, there also. Radio Galaxy Zoo, Radio Jai, Galaxy, Einstein at Home. So RADatHome is there in that list. What did they write? Real Astronomy Discovery at Home is a citizen science project aimed at undergraduate science students in India to work on understanding black hole galaxy coevolution using mainly data from GMRT, one of the SCA pathfinder. SCA will be almost 10 times bigger than the GMRT. GMRT is kind of a leading experiment how SCA will be. So that is why GMRT is the official SCA Pathfinder telescope. The project aims to prove that any BSc BE undergraduate graduate can do multi-wavelength extragalactic astronomy research with the first Indian citizens. Okay, this I have already described to you. So why SCA is noticing this thing? Because the very simple thing, not only we are supported by so many institutions and involving thousands of people in our RADatHome Facebook group, there are 5,000 people, 5 less than 5,000 actually, 5 or 6 less than that. The sky is visible not just like stars in optical. Radio sources are used, very bizarre radio sources, outflows from black holes are there. So that way, GMRT survey, okay, TGSS, is the highest sensitivity, lowest frequency, and the most sensitive and the highest resolution. Highest sensitivity, highest resolution. One can find wonderful things. And that is what is they are interested in. That public is getting trained to use radio telescope, understand radio telescope's images, and they are getting ready for SCA generation when the telescope will come. So this is what is the flying pyramid middle of RADatHome. That institutional facilitator from all those 24 research institutes that I showed you, the logo of. Astronomical collaborators, national and international both, they are helping the RADatHome to fly. I will be sitting here, single man, so small surface area. RADatHome Discovery Camp Committee, the student leader, who are the leaders there, citizens who are the leader there in organizing this activity, and then the 1 week trained citizen scientists, we call them e-astronomer. There are 150 of them. And then you, whoever can make and contribute to making a galaxy image and inserting GMRT image into it and finding something which is unusual, which is new. So what we do, I communicate basically through Facebook to anybody who is sitting at home and trying to learn, trying to look at the GMRT's data and contribute something so that I can lead publishing a paper. So whatever you will discover from home using your laptop, desktop, your mobile phone is also practically possible. We will observe your newfound objects with the GMRT. That will go through the standard international review process. If it is good, then only GMRT will allow observation. So when we publish that newfound data, you will be one of the co-authors, the discoverer of that object. This is the basic gist in one slide, one can say. Many institutions are helping this program to use GMRT's data and make discoveries from GMRT. You can do it through the social media, sitting at home free of cost anywhere in India, kind of bypassing many socio-economic geopolitical problems. So this is what is the publication in 2013. This is what is the publication recent one. You can see that except up to here, they were all student-like thing. Some engineers, some journalists, some student, anybody. Anybody can be a co-author in this co-discoverer of this paper. So we've started in time, so I will not go much, but I will quickly show you that we do not see stars. This kind of a telescope that you see that you are doing astronomy, looking at stars, these are toy telescopes. They cannot produce research result. You have to be the biggest telescope, large telescope, so that this signal to noise, the resolution or the parameter space you are looking at is completely very different, the most sensitive, so that what you see in you can be published. With a magnifying glass in your hand, you cannot discover something about amoeba and bacteria. You need to have a microscope, right? Not few times, few 10 times, but thousands of times you need to resolve. Because otherwise everybody has seen everything else, right? So it is the biggest telescopes that you cannot rotate with your hand actually, or you need machine and huge houses to hold them. 45-meter diameter from one electric pole to another electric pole, huge telescope. You need huge telescope. You cannot buy it, you cannot have it inside home. You have to go to the mountain top. Somebody has to fund you. So practically you cannot have a telescope of your own to publish research in astronomy. You need to have access to the data that these telescopes are making. That is why they make the data free. Because you actually have paid tax, and this becomes country's common property, world civilization's common property. Everybody uses this kind of large telescope, free for all astronomers. That's why it is free for you too. The moment you show your caliber, that you can discover something. So India is participating in several mega projects. Hundreds of millions of dollars will be invested in this kind of machines. 30-meter telescopes, square kilometer array, etc. So there is some kind of job opportunities also coming because of this thing. So let's get ready. Let's be prepared. How do you get selected in these programs? You need to show that you are passionate about this subject area. You need to show that you are already into the area. You need to show that you have made some little progress. Then they will take special interest on you. If everybody has done MSc Physics and everybody waiting to get interviewed in the Astronomy Research Institute, whoever has done an astronomy project in that MSc phase will be given first preference because he already have some experience. Right? So that is why, however small it may be, you need to be taking part in this kind of online projects, online activities, citizen science research. GMRT, this is the size of the telescope is actually compared with the size of the circles here. Sky is being built. See the size of GMRT. Huge. Best of that kind of class. This telescopes. 3 times bigger than the American VLA. So we can do wonderful thing with this telescope. It has already created survey data, 90% of the sky in highest resolution and highest sensitivity in low frequency. It's a gold mine. What are we waiting? This, I have already shown you the teachers because of the sensitivity, because of resolution. We are sitting on a gold mine. Unused data is there. Huge amount of data. So this is what we do in RADatHome. The first step, learn to analyze a galaxy's image in RGB, red, green, blue, 3 channels. Fourth channel with the contour, the line drawing. In RGB images, we are using the first step, NASA's Skyview. We have certain protocol how to make. For example, this is IOU RGB, infrared in red, optical in green, UV in blue, and the fourth one is the radio contour from GMRT. Here is the optical of the same galaxy. Here is another beautiful picture that you see in the website. NASA website, BLE website, American website, mostly European website, and you get amazed by the science. What you can do on your own hand with your own telescope data is this making RGB images and contour images. So learn it from RADatHome and feel of your own, hands-on. Then you can play with the data and try to analyze, is there anything new that the website does not say, the NASA press release does not say, the newspaper Times of India does not say. Because sky is huge. Whole sky is imaged. Whole sky is measured by survey data. But it is not that the whole sky's objects are completely discovered. There are many unknown things waiting to be discovered by you. So this picture I have already described. So TFR's Center for Theoretical Sciences, they hosted one of our 7-day camp. Free food, wonderful environment to work with. We gave training, and next day we gave training to many people also. Okay, so this is what with the GMRT, good right. GMRT observation of objects discovered by RADatHome Astronomical Laboratory. This is the project which is ongoing project with GMRT. This is the you can see the when we observe, except the leading few, everything will be the student and citizens who are participating through RADatHome programs. That if your object is discovered, your project is being observed with GMRT, you will visit GMRT telescope. Sitting in the control room, you can observe your own and be part of the discovery. This Vigyan Samagam, which is by Government of India's DAE and DST and NCSM organized it, public and there also I made I conducted a workshop, citizen science research workshop, discover black holes with RADatHome and GMRT. Using GMRT data, how you can discover exotic black holes. I gave the training to the public. Then after that, they came and participated in our online classes through the Facebook group. This was in NICER, 1 day program. Nearly 100 people can get trained how to make RGB images, how to make contour images, what does this radio contours mean, what does this blue UV optical different meaning of this kind of data. I will give you, corona doesn't really matter in the RADatHome's growth. This is from January 1 to till today. This drop is because I deleted many inactive profiles. And there are 4,495 total members in our RADatHome group. This is nearly 3,000 people are active members. You can see that. More than 500 always. Every month, every week that you can estimate. Number of posts, comments, reactions they do. You can see the comb-like thing simply spikes because every weekend classes actually it goes up. More than 200 comments, reactions or comments happen. This precisely Thursday, maximum number of people are becoming active in our group because Thursday classes, 8 to 9 in the evening, we come live, we discuss. This I have already described. I will come to quickly some discoveries by these members. Okay, so this was one object that it was not looking like a standard FR1 or FR2 radio galaxy. We got confused. It was not giving any clue in the American image. This is Indian image, contour image. So we followed up with GMRT. See the imaging difference. Because these images were taken within less than 5 minutes of looking at the sky. This was taken for 3 hours. See the difference. What is happening? The optical galaxy is here. This has nothing to do with the whatever is seen at the large scale. The black hole was active. It created a plasma jet. It expanded in both directions and stopped creating jet for millions of years. Then it restarted. The second phase of activity is creating this kind of a jet, the pink fellow, here and here. Why black hole does like this? Is it because of another black hole merging here? Is it because something else happens that we don't really understand? Why black hole stops creating jet for millions of years and starts again? And by creating this kind of episodes and multiple energy outflows, they may be actually removing the cold gas from the galaxies, and that is how spiral galaxies after merger may turn into elliptical galaxies without any star formation. They all look yellow. Billions of year old stars only. And for millions of years, they are not forming new stars. For several billions of years, elliptical galaxies are not forming stars. Why? Maybe black hole is the culprit. Another objective. This was supposed to be the host galaxy creating a jet, but you see the relic, like somebody was smoking, you smoked it and left the place, so smoke is all around, diffused. You cannot figure out which way the person was standing while smoking. It is no proper shape anymore. It's a relic of the black hole activity several hundred million years ago. Another one, the jet which was supposed to be this way is different. Maybe because a black hole or some hydronic process, we don't really understand why this plasma coming out from the central black hole is of this shape. So different students, all these things are different students, different RADatHome members have found. Names you can see, Sai Arun and Arpita, Sagar, that was Silpa. This is again Pratik's thing. The galaxy is moving and the geometry observation shows emerging thing. And that is how the moment you find it and it becomes something exotic result, the astronomers don't really understand. You become whatever be your profession, engineer or a journalist or housewife doesn't really matter, student doesn't really matter. You become co-author and you grow your personal happiness or career. Another one. It doesn't belong to any galaxy. Wonderful plasma photograph. This is the TGSS image. This is the our own image with the GMRT follow up. How amazing different. So you see the tiny iceberg, we see the whole iceberg now up to 5 hour observation. So you can because of this thing, then they get my recommendation letter to join foreign universities, do PhD program inside India or outside India. And when you get recommendation letter, I put your discovery picture in the recommendation letter itself. And these institutions actually recognize that, understand that yes, this guy has been interested in astronomy field, already found, already observed with GMRT, and this must be a good person. And that is how they get selected. You can say out of the 150 people that I have trained, nearly 30 of them are doing PhD or MS in astrophysics abroad, US, Europe mostly. There are of course people in Japan, Australia too. So that way it's kind of a free for everybody, kind of a career boosting system. It's helping your growth sitting at home, your career growth. Astronomy research is now being used as a development of career for students anywhere they are. For example, all these three were from Orissa, where there is no astronomy research institute. They are now doing PhD in astronomy. They will come back. This is Pratik, or the senior most member. He's finishing his PhD now from Ayuka Leiden University combined into French project. This is also Charitarth. So this is the map showing that all of our RADatHome senior trained ES numbers are sitting in different parts of the world. 30 out of 150. Govind Swarup, father of Indian radio astronomy, appreciates this thing and always encourages to do discoveries with GMRT. You can see there's not much time there. We will not speak more details about reading his emails. He recently have passed away, and he is the man behind GMRT. Also, the UT radio telescope. India has been a world leader in radio astronomy, primarily due to his leadership there. So my PhD guide, okay, he wrote a very message. How great RADatHome! If I say, you may not believe me, but try to listen some reputed person speaking this. Sorup's message was written here. The new TGSS images available. RADatHome astronomers should hurry up and find gems. Okay. Developing scientific temper and humanity in a spirit of inquiry and reform are enshrined in the Constitution of India. Citizen science projects are an important component in working towards that goal. RADatHome is a significant citizen science project which has touched many parts of the country and enthused young students to take up scientific projects in astronomy. It has also helped expose them to the most powerful radio telescope, the GMRT, built and operated by NCR TIFR. I wish RADatHome all this success. The founding director of ICTS TIFR Bangalore, Spentavodia, he said, it, ICTS, is a platform of new initiatives. For example, you are here. I think this, RADatHome Collaborative basically, I think this is a new initiative of so many people to be looking at the astronomical data and leading to the science out of it. So we have provided the platform, wonderful thing. And the last day of the camp, not only 15, 20 people could be trained. Last day we tried to train 80 people. Everybody was looking at the same galaxy image, trying to understand what is that from coming from GMRT data. He was earlier director of IIA, Indian Institute of Astrophysics. India has a large number of students and even office workers who are excited about space and astronomy, but has not had the opportunity to pursue their passion. Groups such as RADatHome provide such opportunities using publicly available archives from the worldwide astronomical community. The data is there. One has to try to understand what is seen, what is measured, what is missing in the literature in the published paper that you find something as new. Balaya, famous for his gravitational wave research from Indian leader there. He is currently visiting professor in ICTS. Earlier he was in RRI. Starting in 2000, slightly personal, sorry about that. Starting in 2013, mentored solely by your personal passion and vision, RADatHome has grown into a successful citizen science initiative in India today. It has offered intellectually hungry undergraduate and graduate students and amateurs an opportunity to research and contribute to exciting discoveries in astronomy. It mines the excellent data of GMRT and spreads the message of how science works to a larger population in the country. I hope your effort will serve as a model for other branches of astronomy and science. Wishing you all the best. Keep up exciting work. So the point is this, okay, that people should come forward for public participation in astronomy research. Why other astronomy research is not happening in India in citizen science way? Because we don't have that kind of all sky survey data for the public to look at. GMRT is the only world-class facility which has created such a survey and that is sensitive, that is highest in resolution in any frequency possible. So that data is a gold mine that Indian institutions should support more, Indian private companies should support more, Indian public should participate more, and let the discovery happen. I always say this, big data problem can become a big prospect through mega projects and citizen science approach. Because it is a huge amount of data that is unmanageable by professional astronomers, professional scientists. Students are there. Our country is the country, only country, which has largest number of students, scientists or engineers who are all trained in science and engineering can communicate in English language and read and communicate in English and are trained in science, sitting in the internet. No other country has this global competitive edge. So we can achieve research and development sitting at home. Coronavirus spreading pandemic is giving you another lesson that many things we can do online. Rather, we should be doing online as a preparedness for the future. That is why the International Astronomical Union gave a public advisory that people should take benefit of citizen science research in this pandemic time, sitting at home, learn from how to use the time of lockdown time effectively. And they gave an example of RADatHome there as well. People should look at. Though we are not involving international members in the research yet, only in the education part, still they all welcome this kind of model of involving. So join RADatHome Facebook group. Read the notice board, the first or pinned post in the group. We will do after this session. If any one of you are coming, make RGB contour maps using NASA Skyview. Post images there. Different day. Follow the daily galaxy RGBC rule. Different day has been planned for different targets so that we cover various kind of galaxies and discuss them like net practice. Before we do the field match with doing discoveries, we should do net practice, that is the RGB image analysis. So you will be selected as I astronomer group. So if you are doing well in the RGB images in the main group, then we will be selected to I astronomer group where 7 days we will be giving you training. So then we will be joining the digital discovery task. There you will be discovering something new from the GMRT data, 150 megahertz survey data. Be co-investigator in GTAC approved GoodRAC project. You will become a co-investigator in the GMRT proposal, GMRT research. So be RGB analysis trainer and discover, be co-author in paper. Be co-author in conference paper and journalist paper. Grow in your career, contribute to national growth. So this is the science part. Actually, we will be talking some other time. The organizer is saying we may be having a second session some other day. So message is this much, that this is so easy to participate in research. And when we're looking for opportunity for your career growth, the country has already invested money and created data that you can use to make discoveries. Take advantage of it. Don't miss the opportunity. If we miss, who will lose? We, you, me, and the country. We are going to lose. We should take the advantage. We can convert the big data problem into a big prospect, big opportunity, because we have the biggest radio telescope. We have the largest number of students waiting for opportunities, educated already in English and science. Here I will end my talk and look forward to any question that you may be having. Okay. Resmi, I will look forward to questions.
Hello, sir. Okay, that was a lovely talk. I was just looking at the comments, and the most common question that the students are asking is still they do not understand how to exactly, contribute in the research. So, if you can tell them again how they can join the Facebook group about that.
The moment you understand from that RGB images, radio optical radio images, I will tell you what are the standard type of radio sources that the textbook says they are the standard radio sources in the sky. When they are bright or when they are normal, they are boring. They are not interesting. The moment you find something faint and fuzzy that is newly seen to GMRT data, then there is something interesting there. Then I will judge whether that new feature that is the tip of the iceberg is seen, is that a new island? Slightly something you have seen, is that something new opportunity? I will go and look at, yes, it looks like something important scientifically. Then we will go and observe with the GMRT. And eventually, your contribution of spotting that faint and fuzzy new source from the GMRT TGSS data, that will be your contribution. I always give this symbol because my way of telling you what is important is only structure and color of the data. What is scientifically important there is a different thing that you cannot immediately or within a couple of months you cannot understand whether it is important or not important. But what is important is the structure and color of the data. I give this analogy always actually. It's gold. How do you identify? This yellow and shining. As simple as that. But what is atomic number of atomic weight of gold? That's a different issue. That after a certain amount of time you will discover. So everybody has a chance to find something new because the data is world class. So from the RGB
Yes.
image analysis, you will find something new in the DILSE discovery phase from the GMRT data, and that will be followed up with the GMRT advanced study.
Yes. Also, one question is, it's like, are there any prerequisites to participate in any kind of programming or any other technical knowledge, like before joining the group, if there are any prerequisites like that?
See, various citizen science programs have various prerequisites. Some programs are confined to their own country. Germany has some programs like that. Australia has some programs like that. And some programs have their constraints, like RADatHome has a constraint that you need to be a science student at least of any university. Less than that, I do not accept. And so, what kind of constraints are there? You need to look precisely to those particular projects. Otherwise, by definition, citizen science involves n number of people, and there is no qualifying screening process there. To become a member of Red at Home, there is no screening. How much you can grow from the first RGB making group, that is up to your performance.
Okay.
Next.
But to join the group, it's like they need to be a student in an Indian university.
The voice is breaking a little bit. Say again.
To participate, they need to be a student in an Indian university. That is what I'm saying.
No, they can be housewife also. The moment you have finished your BSc or BE or BTech and you are doing any
Mm-hmm.
kind of job, there are 70-year-old people also there. There are just unemployed youth there. Any kind of people can participate in it. Why I need this MSc university membership or the university education is because when I say that this object is ionized, you should not be asking me what is ionized means. When I say
Yes,
that
yes, yes.
plasma is going to flow in straight line, it will not
Mm-hmm.
curl around. Find something
Yeah.
which is curling around and not going in a straight line. What is plasma flowing in straight line? Very simple thing you should not ask. Because I am limited by my explaining power, 24 hour a day, having a job and a family, etc. If I have many people to work for me, I can relax that rules also. If it grows in
Mm.
future bigger, we can have many more relaxations in our constraining rule.
Yes. And also, another student is asking what happens in the classes and how can they participate in the classes. So they're asking
Okay.
about how
Uh,
about the e-class.
Come in the Thursday 8 to 9. The moment I post that Thursday 8 o'clock, I'll be posting a message there that today we will be looking at these galaxies. You will be knowing how to make an RGB image of those galaxies. And I will be asking what is peculiar, what is strange, what is important, what you want to discuss among these galaxies. The moment you spot what is abnormal there, for example, a galaxy should looking like a spiral, galaxy should looking like a elliptical, and you find some galaxy which is not looking like a spiral or elliptical. There is something to understand there. So that way
Yes, sir.
you will be telling me what you want to learn, what did you not know that we will know now. So that 1 hour we'll be discussing something, and after a certain amount of net practice, we are ready to look at the radio optical UV images of galaxies and know basically what is normal, what is not normal. Then you are ready for kind of making a discovery. And what will be the starting point of the discovery? Finding something which was not seen in the previous data, finding something very faint and fuzzy and new basically, because we are looking at the highest resolution, highest sensitivity data of the sky. From there, your discovery starts. I will be
Yes, sir.
posting, you will be commenting images and text, and that is how the discussion goes in.
Yes, sir. And also, there was a technical question that some massive black holes contain huge amount of mass equal to thousands suns. So, does it produce the same amount of gravitational wave also? So, they are just asking a technical question about gravitational wave.
See, you may have heard about this gravitational wave discovery, first one. Say, for example, like hydrogen fusion. The hydrogen, four hydrogen mass, and the helium that has formed on the right hand side, there is a mass deficit. That deficit del m c square will be converted to energy in heat and various particles. Okay. Very similarly, when supermassive black holes, two galaxies merging, two intermediate mass black holes merging, say 20 solar mass and 30 solar mass, two black holes merge. The ultimate black hole, the remnant or the final black hole, will be having certain amount of less than the first two added. So that less amount will be released in the gravitational wave process. So it's certainly very small fraction of the masses of the black hole that is released in the process of gravitational wave, electromagnetic, or whatever it is. Cannot be same amount. Cannot be same amount. Same amount will be
Yes,
huge. Everything cannot be converted to energy. There is no process like that, except the pair formation and pair annihilation thing. There is no process that whole mass can be converted to energy or very similar amount can be converted. It's not possible. I hope I understood your questions correctly.
yes,
Same
yes,
amount, if similar amount can be released, who was asking, I guess.
yes, yes. Like they were comparing the sun and thousand sun, like how the gravitational wave. Uh,
The black hole's mass at the centers of galaxies
hmm,
are million to billion times mass of our sun. For
sun.
example, this spiral galaxy, like normal spiral galaxy like ours, few million times, for which people got Nobel Prize this year. But
Hmm.
the radio galaxies that primarily GMRT TGSS survey will see that we discover actually, those kind of things are billion times mass of the sun. They are sitting at the centers of giant elliptical galaxies because elliptical galaxies are primarily mostly have grown because of merging of so many spiral galaxies. Those science aspects we will talk some other time. So, but that is
Yes.
precisely the point that I forgot. What was the question? I forgot.
The question was related to the gravitational wave, the energy that is released, the gravitation.
Yeah, very small amount get released.
Yeah. Yes. Sir.
And
Also,
okay.
it's like yes, the student has understood it. Also, like again and again they're asking like what to do after joining the Facebook group. So you will find the link to the Facebook group in our description of this live, and you should apply to join that group. You can find more about RD. I have even provided the link to their website. So, like, apply to the group, read about more about RAD on the website, and then wait to get accepted. As soon as you get accepted, there will be rules, other description. You can go through that. You can see what other members are doing. So I think that will be a very good way. It's like if they are still uncertain, they can just apply to the Facebook group and then get started.
See, soon after this session, we will be having a practice of how to make RGB image. But
Yes.
RGB image is not the discovery. RGB image making every Thursday that we do is not doing discovery. It
Mhm.
is discovery happens only after you are well experienced in RGB image analysis, so that you get the GMRT report data. You try to find something new which is not known, not published before. So you need to know what is not known, what is new, and where do people publish and how to search whether a galaxy is published or not published. So there you need kind of several days of training. So actually,
Yes.
if you say that I found something new, who has the time to look at everybody saying that I found something new galaxy? So you have to be a credible person with certain amount of training and trust already built up in the system, that I will spend some time in looking into your object. Like I have a certain duty, official duty also. I cannot look at every person's comment that this is a new discovery. So what I will do, I will say that let go through a systematic hierarchical process. Let your RGB making members interesting fact that you think interesting is looked at by the 1 week trained astronomers. If they also say that this is something interesting, sir, then I am coming to the picture. Then I will go and take that object to my collaborators who are scientists in different institutes. Then we will discuss whether this is interesting, important, and feasible to be able to be analyzed with the GMRT. It may be important, but it is not possible to forward that further. You may need a
Mhm.
different telescope. So there we
Yes.
are not going
Yes.
to follow it up. We will keep it in the repository. We call it first investigation report actually. And we will be keeping your
Yes.
report there for future study. So if it is important and interesting and easy to do it immediately, we will do it immediately and try to go ahead. So every small contribution of finding a new object in GMRT data, when you become eye astronomer from RGB image making group, then you are starting contribute to GMRT research already. You file a FIR so for us to analyze further. There are various steps. That's why I draw the flying pyramid model. Starting point is the base of the pyramid, RGB making.
Mm. Yes. Yes. So it's like
I think
there's
we will
not just one
participate.
level. So, apart than that, one student is also asking, does gravitational lensing affect radio galaxy data too?
Yes, gravitational lensing affects light. So that means radio wave is also a light. And there are radio lenses as well. Okay. There are radio lenses as well. Whatever light source is the central galaxy, if that is seen like a ring, a radio source behind that will also be seen like a ring. Muti
Mm-hmm.
Radio Telescope also has a very nice discovery of a radio lens. Muti radio lens, people call it in literature sometimes. So radio lenses are also possible. ALMA has seen many lens images, and ALMA is a radio telescope, very high frequency, of course. Several instead of gigahertz, 1400 gigahertz, it can be 900 gigahertz. GMRT observing in 300 megahertz, ALMA observes 900 gigahertz. So very high frequency, but that also sees many radio lenses. VLA has also many radio lenses, right? Yeah.
Yes, and then they still have a query that radio waves cannot be seen. So how are we seeing? Radio waves cannot be seen with our eyes, so they have that kind of doubt as well. But yeah, like a radio telescope do make images. That the procedure is just different.
I will give you two indirect examples. Uh, Everything which is radiating light, if it is a black body like our sun, if you take the spectrum, black body spectrum, it is peaking in the optical. But the tail end of this spectrum comes in infrared, submillimeter, radio as well. So the object will look exactly similar if you take the blackbody spectrum and the other way also. Depending on the temperature, it will become UV, it will become X-ray. So how it is imaged, there is no photographic plate. Only recently MIT has started designing some kind of a lens for radio. Radio gets reflected very easily, but image does not form and there is no way to capture it like a photographic plate or CCD. So what we do is like the first analogy will be looking at double slit experiment, like a light source, and there are two slits at the center. You get the constructive interference, next destructive interference, next constructive, next destructive. So it's like a pattern. Radio wave is also going to do the same interference pattern. Distance between two antenna, constructive interference in the middle, destructive, constructive, destructive. That way, if you have multiple antenna and multiple sources, then you know the instrument, you can recreate, calculate back what kind of source distribution in the sky. That's what is a aperture synthesis imaging in radio astronomy. And it was so interesting and so amazing, that is why they got Nobel Prize. What we do actually exactly like an MRI does, we do kind of synthesize a lens by different small unit. Like EGMRT is a dish antenna of 25 kilometer, but there are only 30 points where we are sampling the radio telescope. It's a complicated thing, but it is real image.
Yes, yes. Also, there was a question that for finding out new trend in galaxies, like making discovery. So, do we should have some solid foundational about past galaxies discovery, or by simply general knowledge can help us to distinguish it? So, to find a new kind of galaxy, do we need to have some solid foundational about how past galaxies or how past discoveries were made, or some foundational or general knowledge can just help us? So how much background knowledge do they need to make a new
So
discovery?
that's precisely the point that anybody doing anything in astronomy using the data does not make him a citizen scientist. Anybody finding anything in the new data, you call it a new discovery, but nobody is going to publish your paper, because you need to first give an evidence that this is scientifically important, considered by the fellow scientist. This is not known, considered the publication databases. So there is proper way actually. Even if you say that I have not done the crime, you need a lawyer to say that, because the judge and the lawyer talk in a particular language that you don't talk, right? So similarly, a finding that you do as a citizen science discovery, when I consider it important, I consider it important not by looking at the image only, but by realizing what is new in that image that I have not seen in past 20 years of my research career in extragalactic astronomy, radio astronomy research. That experience of what is known and what is unknown has to be coming from a guide, has to be verified by the standard databases and standard procedure that the astronomers or the scientists publish papers in. That is why I give training for 7 days, not only to understand the significant truth or false, that value of the image, but also where to check and how to check with the astronomical jargons in the NASA extragalactic database page and the NASA IDS publication, to figure out whether this is new or this is known. You can find a galaxy which is looking interesting, but there may be 1,000 paper written. If that interesting looking thing doesn't have a paper, there is actually an opportunity to write a paper.
Yes.
That's why you need a guide.
Yeah, so it's like even though they have a limited amount of knowledge, you will be having the guidance officer throughout.
Yeah.
And whenever you find something new, sir can tell you like how much new it is and how much like, can you make a discovery out of it? Can you make it publish? So all of these things you can discuss them with sir later, like when you are in the group and when you are making and analyzing all these images. So one question I wanted to ask is like till now, as we saw in the beginning, there is only one project that is in citizen science, in physics and astronomy. There is just one project. All of them other have to do with biology, nature, and wildlife. All these kind of projects. So it's like if we want more projects, not just in astronomy but in the other fields of science, there is like other the other things. There is chemistry, and then there is, let's say, mathematics. So it's like, what should be done so that there are other projects as well, because scientists, they are doing their job, students, they are doing their job. There is not that bridge between them yet.
See, there are basic two distinction of what citizen science does.
Hmm.
One is who employ public in collecting data.
Hmm.
This is one category. The other category is who provide the data from who employ the public in analyzing them. Okay. So in India, when I said astronomy research is not happening except GMRT, TGSS, RADatHome, etc., it is
Hmm.
because other telescopes are there who are doing research and publishing, but they have not done this kind of a sky survey to provide the unpublished new data to the public and welcome them to participate. Okay. The other variety, if you want to do in other topic other than astronomy, you need to have an instrument of the world class research quality instrument to provide data to the public, or design or instrument the other way, center outwards or outward to center. Other way means you design some experiment which will be collecting data from different parts of India and providing it to a central database which will be looked at by a professional scientist.
Yes, sir. Yes, sir.
So either of these two model you can follow. The biodiversity environmental model is following the second one, outward to center. They are only collecting data mostly by their photographic camera or mobile camera or counting of the birds or etc. etc. But the first one, astronomy radiotom model, the center outward kind of thing. The data is
Yes.
created and distributed. For this, you need to have a machine which will produce that kind of quality data. So that is why actually small institutions cannot produce that kind of thing.
Mm-hmm.
Because if you can produce that person who will pay you the money, and if I have the money, I will publish papers myself. Only when I allow public to participate, when it becomes unmanageable for myself. That's what happens in astronomy always. Because the survey mode.
Yes, sir. So we have so much data in astronomy to that we need help of citizens and other people. So it's easier to make a citizen science project when we have very much data, big data we have. So my question is, it's like you started this online classes and online group in 2030. And this year, is there a massive increase in the number of students because of the pandemic? Because even before the virus came, all the classes were being held online only, and now it's like the first question is like, has the pandemic changed anything in how the RAD classes are going? And it's
No,
the other question is like
no,
you had since 2013 the online classes have been ongoing. So like, what was the reason for that? That you chose online classes and not just teaching students who are in your institution or nearby where you were teaching and you were
no,
working.
no, no. My institution's student is a different question. And the
Hmm.
coronavirus thing has not changed at home because the education and research that has been happening in Reddit home online is since 2013.
Yeah.
And today only because of corona, the public outreach talk and various research talk are being available online, and making the talk available, the high class big scientist talk available in YouTube, or interacting with the public for that question answer session 5-10 minutes or half an hour or 1 hour after the talk, that is
Yes, sir.
not sufficient. You need to redesign how do you involve public in research. That redesigning has to be somebody giving enough training, enough care, enough selection process, that I cannot entertain public's any question. My topic, that is why in RADatHome, no topic is allowed to be posted. There is a conference happening there is a meeting happening there is a sky watch happening there. Those things are not allowed in RADatHome. It is only focusing on understanding galaxy images, UV, optical, IR, and precisely radio important. If you are not focusing on galaxy understanding, I would be very strong and remove you from the group. Even with this kind of strong message, there are people growing, they are not able to contribute. That's a different thing. We are not able to make them probably welcome and amplify, simplify them so easily. But that is the rule, that we have to focus on a particular way of understanding thing. Only then you can progress towards research. I
Yes, sir.
think yes.
So that were most of the questions, and some students have said that they had joined in late, and then they will be watching the session from the beginning, and then they will be asking the questions. So for any more questions, it's like the best thing would be to join the Facebook group, and you can find the description again here, or you can just Google RAD at home, and you will be, getting the Facebook group link, of course. And you can ask all of the questions, like whatever doubts you have, and you can start analyzing. So today in the session, like in the lecture, you understood like what is citizen science, because I'm hoping that most of the students, Indian students, they're not aware of the opportunities that citizen science has to offer. So through this particular lecture, I hope those were at least clear, and now you have a basic understanding of what citizen science is. You can start joining and do your contribution and start understanding astronomy on an even greater scale. Like I have been part of RAD, and I'm hoping to see like whosoever has attended. If you are interested in astronomy and citizen science, you can join that group, and hopefully you will be progressing more in that way. So the students are also thank you. So I'll be also saying thank you, sir. Thank you for your time today. Like this is very great because, as you pointed out, there is very less awareness related to citizen science, and I'm very happy that this model, keeping the classes online, and they were like already, even though everything has become online now, your classes were unaffected because they were already, you know, you don't have to do much work regarding that. They were always online, so they did not get affected. So I'm happy for that.
I have a saying, I have
Yes, sir.
something to say. It is almost 7:20, and we are
Yeah.
about to close our online broadcast. So for till 7:30, if
Hmm.
anybody is interested further, till
Hmm.
7:30, I will be waiting in the Reddit Home group to accept you and discuss with you whoever is interested. So till 7:30, I will be waiting for your joining request, and we will be discussing further anything if somebody is seriously interested now.
Yes,
All
yes.
of you are welcome anytime to join if you are busy with Diwali or anything else. As
Yeah.
Thursday, 8 to 9 in the evening, we will be coming online and discussing this thing. Thank you very much for the opportunity. And it's our responsibility to make publications from GMRT, from discoveries from our own telescope GMRT.
Yes, sir. Thank you, sir. So all of you have heard. If you just go straight away, so we'll be waiting for you. You can just get. They can accept your request as soon as possible. So all of you can, start your citizen science research today only. And yes. So thank you everyone for attending, and have a great day. Bye.
Thank you. Thank you very much. Thanks, everybody.
Thank
See you there. Bye.
you.